Hey guys, in this video I'm going to show you how to linearize your exponential functions in Excel. So I only have two columns of data here. I have my population data and my iterations. And I include a zero iteration where I have a population that starts at 30. And then this is where we roll the dice, and 4 of my dice landed with a 1, rolled a 1, so I removed those dice and I'm down to 26. After my second iteration, I had to remove 6 dice, so I'm down to 20, so on and so forth until I got through the 10th iteration and I had only 4 dice remaining. So I will go to the Insert tab and I'm going to insert a scatter plot, and I can either right-click, go to Select Data, or I can click Select Data up here. I'm going to go to the Select Data, and I will add, and this will be my dice population over time. My x values will be the iterations. Those are my independent variables, so iterations 0 through 10. And my y value, I keep the equal sign, and it goes from 30 to 4. Okay. Don't forget to add your axes titles. So this will be iterations, of course. Let's see. Iteration. And this will be my dice population. And you can see in this, there's no uncertainty in either the iteration or the population because it's a strict count. In the future, we will account for uncertainty. I will now go to the chart elements again, the green plus. I will add a trend line, but I will need to go to more options. This, I need to choose the vertical green arrow bars, and this is an exponential function. Let me take off this trend line. Click that off. Go to more functions here, more options. Make sure you only have the exponential function. And then scroll down to display equation on chart, and you can see that this is my equation 31.45 for e negative 0.185x. Okay, great. Now let's see how to linearize said functions. So I'm going to go to ln, I will title this ln population, and this will be equals the natural log of 30. So I do not take the natural log of my independent variable, in this case my iterations. I only take the natural log of my population, my dependent variable. So equals ln open parentheses 30 close parentheses. And now if I click this entry and I go to the bottom right hand corner, this black cross appears and I can scroll all the way down until my 12th entry and it auto-populates for me. Now my function will be linearized. So I will go to insert a second graph. So I'll go insert, another chart, a scatter chart. Here we go. Sometimes there's a little bit of lag. I will select data, add. This is my linearized dice population. My x values stay the same. It's still my iteration 0 through 10. My y values this time, however, are the ln of the population. Now you can see I have a smooth linear function versus a smooth curve. So same thing, I need my axes titles. This will be my ln the population, natural log of the population. And the interesting thing is when you take the natural log of a measurement, you lose the units. So when you have a function with natural log values, it's a unitless number. Even though population in this case is unitless, it's just a count. If I had to do the natural log of volume, I would not have ln volume in cubic millimeters. There would be no units. It's dimensionless. These are again my iterations. I will add a trend line again, more options, these green vertical bars, and I want to display the equation on the chart. And you can see this is indeed the natural log of this equation is the this equation is the linearized function of this equation. So I hope you found this video helpful. Use it as your guide in future experiments where you do need to linearize functions. Best of luck to you this year, and thanks for watching.